Hi everyone, Goldie here, and I'm ready to make coding concepts easy to understand. In this video, we are going to be going over the AP CSP robot. Now, the robot is a feature in the AP CSP course that allows the AP exam to test you on your coding knowledge as well as coding logic. And it does so in the form of a quote-unquote robot. So I'm going to go over the basic commands of the robot and then go through some examples of how they might use the robot to help evaluate your coding ability. So if you're ready, go ahead and get buckled in and let's go over this content together today. So first we got to define what exactly this robot is. So because the course is taught with a variety of programming languages, the AP exam needed a way to evaluate your programming ability. And some of that is in the multiple choice questions that we have seen so far. But another method of evaluation they use on the exam is called the robot. Now, the robot is represented as a triangle on a grid of squares. And code is given to simulate the movement of the robot on the grid in some way. And you'll be asked different types of questions about its movement, and we'll see that a lot in the practice. So these notes I just want to give you as an introduction into what exactly the robot is. So here would be a picture of what you might see on the exam and a little bit about what the directions are going to say. So it'll visually describe what you are looking at. So it'll say something like the grid contains a robot represented as a triangle. So you can see the triangle right over here. And this tip right here of the triangle, it's usually an isosceles triangle. So the tip of the triangle is representing which direction the robot, the triangle, is facing. So in the directions, it'll say the robot is initially facing right, because you can see in the grid that tip of the triangle is to the right side of that box that the robot is in. And then it'll say the robot can move into a white or a gray square, but cannot move into a black region. So sometimes you'll see an open grid with no black or gray squares, and sometimes you'll see a few of them. Okay, so the black squares, they can't move into the black squares at all. And usually on the exam, a grid, a square is going to be gray because it wants the robot to end up in that destination. So you'll see some exam questions with the gray square, and sometimes it won't have a gray square. Additionally, your AP exam reference sheet has all of the robot commands that are going to be given. And it also says this: if the robot attempts to move to a square that is not open or is trying to move beyond the edge of the grid, the robot stays in its current location and the program will terminate. So that means the robot is not allowed to move in those black squares, and it's not allowed to move off the grid at all. Okay, so let's go over the basic robot commands. Now, these are going to be included in your exam reference sheet, so you will see them and be able to reference them throughout the exam if you forget. But let's explain what they do. So the first command is going to be move forward. So you can see it takes the form of a procedure. So this helps us practice that procedural abstraction, right? So we're not actually going to see the code that moves the robot forward. We're just going to use this procedure as a command to move the robot forward. So it moves the robot forward one square in the direction it is facing. Okay, so it actually moves one square ahead, but in the direction it's facing. So I have a couple of examples here. Where does the robot end up after one move forward command? Draw its location in the provided grid. So I have it here. It starts here. Identify where the tip is. Okay, that's the first thing you should do when you are looking at your robot, is which direction it's facing. Where is that tip? So here I'm facing up. So if I use one move forward command, that triangle is going to move up one. So I get this triangle now. Okay, and it's red just to show that that's the answer, right? It moved forward one grid. And it stays, or one square, I should say, and it stays facing the same direction when you move forward. Okay? Something like this, it's in the middle, Again, I identify my tip there. It's facing to the right. So if it moves forward, it's going to move one square over to the right, and it's still going to be facing to the right. Okay. So that's your move forward command. The next two commands are the rotate commands. So the first one is rotate left. This command will rotate the robot in place 90% counterclockwise because you're moving it to the left. Okay? An in-place left turn. And then rotate right is the other direction. It rotates the robot in place 90 degrees clockwise, and it makes an in-place right turn. So these examples draw the location under ending direction. So when this robot is on the grid and in a square, rotate left and rotate right just rotate it. It does not move squares at all. Okay? So if this was the initial direction, I am facing up, or yeah, I would say up on the paper, right? I'm looking at the paper or I'm looking at my screen. It is facing in the upwards direction. If I give the command rotate right, okay, think of this like a 90-degree grid here, okay? Actually, I don't want, that's misleading. Let me erase that real quick. I don't want to draw the grid on it. Okay, this is the direction. I want to draw the grid similar to this. Okay, so if I rotate to the right, that means I'm going to rotate 90 degrees to the right. So if I'm facing up or facing forward and I want to rotate to the right, I'm going to rotate 90 degrees and face off to the right side. So ending position, I am over here facing to the right. Here I have, this is my starting position. And again, I'm kind of having it right here. I'm going to rotate to the right. So if I'm facing this direction, again, you kind of have to orientate yourself now. Okay? So if I'm facing off to this direction and I want to rotate right would be here, right? Like this is my left side. This is my right side. Okay? So I'm going to rotate right, which means my ending direction, I'm going to be pointing down. So with these rotate commands, you really have to put yourself almost in the robot's position, right? And think, okay, if I'm rotating to my right side, I'm going to turn to where my right hand would be, and I'm going to face that direction. So here, it's facing downwards. Okay? So it's facing downwards, and if I want to rotate right, okay, put yourself in that position. If I'm facing down, my right hand is going to be on this side, and I'm going to rotate here. Okay, and so my ending direction, I'm going to be facing off to the left. Okay, and then the last piece, if I'm facing to the left, okay, and again, put yourself in this position. If I'm facing this way, where would my right hand be to turn me? It would turn me this direction. So my ending direction, I would be facing up. Okay, so the rotate commands do take some time to get used to. And that's okay. If you're working it out on paper, you can draw. I always like, drawing on the tip and making a little grid just to kind of orientate myself. If you're looking at a screen, you'll have to get used to visualizing it on the screen and rotating it yourself as well. It just takes some practice. Okay, just take some practice. Let's look at rotating to the left command. So if my initial direction is facing up here, again, that if I orientate myself and I want to turn towards my left hand, I would be turning this way, okay, what we call counterclockwise. So if I turn that way, now my tip is going to be over here. Okay, so, erase that. So now my tip is going to be over here. So my ending direction is going to be off to the left, okay, with my tip facing this direction. Okay, if my tip of my robot is over here. Okay, orientate yourself. Okay, visualize yourself on that location. Which way is going to be your left hand, and you're going to want to turn that way. Okay, so I'm going to be turning this way, and that's going to make me face upwards. Okay. So I always like orientating myself and then figuring out, okay, which direction is my left hand, which direction is my right hand, right? If you're someone that does better with clockwise and counterclockwise, rotate left always turns counterclockwise, and rotate right always turns clockwise. Okay. If that makes more sense to you, if that's how you want to think about it, feel free. Or you can just kind of put yourself in that robot position. Okay. So again, here's the robot currently facing down. Okay. If I orientate myself there, where's my left hand going to go? And my left, if I turn to my left, okay, I'm going to be rotating counterclockwise. And I'm going to end up over here. Okay. Don't feel like you need to get it right away. Okay. Draw it if you want to draw the grid, orientate yourself. Don't feel like you have to, like if you're not getting it right away, you're failing at this. It just takes some practice because it's brand new. Okay. Rotate to the left. Okay. My left hand would be on this side if I'm facing that way. So this is going to end up in a downward position. Okay. The rotate commands, we're going to practice those a lot. Practice, practice, practice. Okay, and the last, not really a command, but the last robot procedure that we are going to use is the can move. So it says can move. It's a procedure that basically asks a question. Can the robot move in this direction? So the command will ask a question with a parameter. In parentheses there, it's going to have a direction, whether that's forward, left, right, or sometimes backwards. And if it can move that direction, in other words, if there's an open square, which means a white or a gray square, in the direction relative to where the robot is facing, it'll evaluate to true, saying yes, the robot can move in that direction. Otherwise, it'll evaluate to false if it can't. Okay. The value of the direction, again, it can be left, right, forward, or backward relative to the direction the robot is facing. So again, we have to put ourselves in the robot's shoes there. The command, does not actually move the robot. All it does is just ask a question and returns true or false. Okay? It does not move it in that direction. It just asks the question. So I have a few examples of what that looks like here. So for this first one, there's 6 of them here, 6 examples. For the following robots, answer if the command will evaluate to true or false given the position on this grid. So if I say can move forward, so here is my robot. It is facing off to the right direction, and I want to know, can this robot move forward? Okay, does this robot have the ability to move forward? And it does. It would evaluate to true. Okay. Doesn't move it, but just evaluates to true. Yes, it can move forward. If I look at this robot, okay, here's the direction. Can it move forward? And in this case, it can't. Robots can't move off the grid. So this would evaluate to false. Okay. Here. Now, when it asks if it can move right, okay, in order to move to the right, we would have to rotate and move forward. Okay. So when you think of this question, think, is the space to the right of the robot available? Okay. So if my robot's facing here, which direction is off to the right? Okay. Again, orientate yourself. The right is this grid right here. So does it have the ability to move there? Could I give it commands to move there? You can, because it's open. Okay. It is an open white square. Right. Now down here, can it move to the left? Again, which direction, which square is to the left? That would be this one. Okay. Truly, it wouldn't matter either way because both of those grids were open. Okay. Now this one, if I put it here, can I move to the left? Okay. Which, I would say square, but one of them is not a square, right? Which direction would be to the left of that robot? That would be over here. Now, can it move in that direction? No, because it's off the grid, so it would be false. And the last one is backwards, right? So if I'm facing this direction, backwards would be back here, and that goes off the grid, so it would be false. Okay. So it just asks a question, and when we ask a question, that's usually going to be in an if statement or in a loop of some kind that helps us make a decision about how to move the robot. Okay. All right. Now let's move on to some code. I know we're excited for it. I have 6 examples here we are going to just trace through the code and see where the robot ends after it is executed. We're going to see other practice problems involving the robot. They ask different types of questions about the robot in the code. For right now, I just want to get used to the robot moving around on the grid so we can understand how it moves around. So we see the grid over to the right here. We see our triangle. Right now it's facing in the upwards direction, and I have some black squares that I can't move on. Perfect. Okay, let's trace through this code. I'm going to highlight in green kind of the code we're looking at as we go through here. So it says repeat until can move forward equals false. Ooh, so we're starting off with a huge line here. So we're starting off with a loop. We're looking at can move forward equals false. So that means we're asking a question. Can this robot move forward? Is this robot have the ability to move forward? Starting off right now, it does. It's true. And I want to repeat this segment of code, which is move forward. I want to repeat until it's false. In other words, I want to move forward until I can't move forward anymore. Okay? And that can be a good way to help you understand when you're tracing through this code. Okay? What is this code trying to do? Well, in plain terms, it's trying to move the robot forward until it can't move forward anymore. Okay? Repeat until can move forward equals false. We want to move the robot until it can't move forward anymore. So I'm going to do that. I'm going to move it forward, move it forward. I've reached the point where I can't move forward anymore because it's black. So that means my loop is done. Okay. Repeat until can move forward equals false. It is now false, and that loop is done. I can move on to my next statement. Now, this next statement is an if-else statement, okay? Technically, these kind of go together right here, right? If can move to the right, I want to rotate to the right, okay? So if I look at this, which is to the right, it's going to be this grid right here. Can I move to the right? Well, yes, I can. That is true. Perfect. So that is true. So if it's true, I'm going to rotate to the right, okay? So I rotated from upward facing to the right. Okay. Now my else, it's in red right here because it gets skipped. Okay, it doesn't run. Because this was true and I rotated to the right, the else gets skipped. And then I have one more code segment. Be careful, don't skip these. It's outside of my if else, and it says move forward. And that's where my robot ends up. I move forward because it was facing to the right, so I move forward in that position. And now my robot is done. That is where the robot ends up after that code has executed. Okay. This next one, here we go. Okay. I always like drawing the little head on there. I don't know. So we're facing up initially. Perfect. And now I have a few loops here. So it says repeat 3 times, move forward. Okay. So again, if you want to trace through it, go line by line, that's fine. But what is this doing? It's moving the triangle, the robot, 3 times. It moves forward 1, 2, 3. So I can tell you that it's going to end up right here after that green code executes. 1, 2, 3. Repeat 3 times. Right. Next, I have just a rotate right. There's no loop, there's no if statement, just rotate to the right. So in this position, I would rotate to the right, which would be this right here. Okay, so now we're facing off to the right. And then I have repeat 3 times, move forward. So I have 1, 2, 3. And that's where my robot ends up. Okay. Not too bad, hopefully. Hopefully we're getting a little used to how the robot moves around. So let's step it up a notch here. Okay, I love this. So again, I'm off, I'm facing to the right. I'm in this bottom square. There's no black spaces here. How am I going to move across this grid? Okay. The first is rotate left, right out of the gate. So again, I'm facing this direction. If you got to draw, that's fine. Where is left? Left is going to rotate me this way. Okay. So now I'm going to be facing up. My next is a repeat 3 times, move forward. So I'm going to do 1, 2, 3, move my robot forward 3 times. Then I have a rotate to the left again. So here I am. Which way is left? That's going to be this way, counterclockwise. So you're going to see my tip is now facing off to this side. And then I have a repeat 2 times. It says move forward, rotate right. So I'm going to repeat that twice. So you'll see my robot move forward and then rotate right. All right. Let me go back there. So move forward, I moved into this. And then my next step was rotate to the right. Okay. So orientate yourself. I'm going to rotate to the right here. So now it's facing upward. And that was for 1 time through. I'm going to do it again. Move forward and rotate right. So again, I was right here. I moved forward. And then I rotate to the right. And that's the ending position of that robot. Okay. I have 3 more examples, each getting more exciting as we go through. Okay. So for this one, repeat 3 times. Everything is in this loop here. Everything. Okay. And I'm going to repeat this 3 times. So you'll see I'm going to keep a little tally here just as a visual. I'm initially facing down and I'm going to ask a question. If can move forward. Okay. So right now, with the direction I'm facing, can I move forward? That is true. Okay. Which is why I'm going to execute these 3 lines of code and I'm going to skip this. Okay, because it evaluates to true. So I'm going to move forward, and then I'm going to rotate to the left. Okay. So you're going to see me move forward twice. I'm going to be right here. And then when I go to rotate to the left, which direction am I going to go? I'm going to go counterclockwise to the left. Okay. So here's what that looks like. Move forward, rotate left. So now I'm facing this direction. Okay. So that ended my if statement. I skipped my else, and that was 1 time through my repeat 3 times. So now I'm going to make another tally, and I'm going to go through again and ask the same question. If can move forward. Okay. So right now, can I move forward in the direction I am facing? No, I can't. That's false. I can't move forward. Right? So because this is false, that means this time the if statement gets skipped and I run the else statement. And the else statement is going to rotate me right. Okay. So let me go back there. Okay. So the else statement takes me and just rotates me to the right. Okay. Rotate right. So now I'm facing down. And that was the 2nd time through my loop. Now for a 3rd time and the final time, okay, I ask the question again, can I move forward? Okay, can move forward. This is going to return true because the box in front of me, the grid in front of me is available. So because it's true, I'm going to run these 3 lines of code again, and I'm going to skip this else statement. Okay. So you'll see move forward, and then the rotate to the left. Make sure I don't misspeak again. Rotate to the left. Which direction am I going to go? Rotate to the left. Counterclockwise. So I'm going to end up right here. That's 3 times through the loop, and that's where the robot ends up. Another interesting one. Okay. So this whole thing is in a repeat until can move forward equals false. Okay. So in plain words, what does this mean? Because I always think that kind of helps us understand what's going to happen. This means I'm going to just keep doing this code until I can't move forward anymore. I can't move forward. Okay. So repeat until I can't move forward. So what am I going to repeat? Well, I'm going to ask a question in here. My if statement. If I can move left. So right now I'm off. I'm facing to the right. Can I move left? Okay. So left would be this direction. Can I move here? Yes. True. Okay. So then inside, what happens? Okay. Well, inside, I'm actually given code to move it to the left. Okay. So it says, okay, since you can move left, you're going to rotate to the left. Okay. So then your arrow, or excuse me, your triangle will be facing up, and then you're going to move forward. Okay. So that's what you're going to see. You're going to see my triangle turn because it rotated left, and then it's going to move forward. My else statement gets skipped. And I go back up and I ask this question, okay? And remember, the question was, are you able to move forward, right? Can you move forward? Yes, I can, because right now the direction I am facing is open. So yes, I can move forward. So that means I am going to run this loop again, okay? So I'm going to ask the question, can you move to the left, okay? So again, the left now, that's off to, since I'm facing up, the left would be this grid over here. This grid over here. So can I move to the left? Yes, it's available. So I'm going to run this code. I'm going to rotate left and move forward. Rotate left, move forward. Else statement gets skipped again, and I go back and I ask and I check this condition. Can move forward. Does it equal false? Yes, it does. Okay. Yes, it does. And because this is false, I'm done. Okay. The loop ends because everything was inside of that repeat until. Okay. So now can move forward is false. Now this can be kind of tricky because you might get wrapped up in the, oh, well, I can move to the left. Why don't I run this code? But please don't get caught in that trap, because we always have to check that loop condition when we come out of this. We always have to ask this question. And because the can move forward is false, I am done. Even if I can execute more code in here, I'm done. The condition, false equals false, and I repeat it until those things were in agreement with each other. False equals false. Okay. This is the last one. Okay. The last example I have here is actually a nested loop. Okay. So we don't have a lot of nested loops on the exam. This would be one of the times we would use them though, and they would test your logic on it. Okay. So repeat 3 times. Notice it is nested. Repeat 3 times, repeat 2 times. I have a move forward, and then I have a rotate left on the outside of this. Okay. Now, if that's confusing, that's okay. Let's trace through this. I always like a good tally when we have a lot of things happening here. So my first time through, I'm going to run into this second loop, and it says move forward, move forward. Okay. So let me go back here. So my first time through the loop, I go into this loop, and it says move forward twice, right? So I'm going to move forward and move forward. So that's why I ended up in that position. Now this rotate left is outside of that loop. Okay? So I move forward twice, and then I'm going to rotate to the left direction. Okay? Left is over here, so you're going to see the triangle turn to face in the left direction. Move forward, rotate left, turn left. There it is. Okay? And that was one time through my loop. Okay? That was the one time through my loop. So now I'm going to keep track. I'm going to go the second time through my loop. And the second time, I'm going to repeat twice. I'm going to move forward. Okay? My triangle is going to be facing here. And then I'm going to rotate to the left. So I'm going to rotate in this direction, and you'll see my triangle get pointed downward. So I'm going to move forward, rotate left. And now the triangle is down. So that brings me to the end of that loop. The second time through, we are done, but we repeat 3 times. So we got to go through one more time. So one more time, repeat, move forward. So the triangle is going to be, if I can draw it correctly here, this way. And then I'm going to rotate to the left. Move forward, rotate left. And it turns red because you're done. That is the end. You have gone through 3 times and the code has ended. And that wraps up today's lesson on the AP CSP robot. I hope that you have enjoyed this video and that the robot concept is much easier to understand now after going through it a bit. If you enjoyed this video, please hit the like button and subscribe to my YouTube channel for more great CS content. Until then, keep coding, keep learning, and I will see you in the next video.